Hello everybody. Okay, so in this video we're going to be going over the nature of roots. So we're going to be looking at the nature of quadratic functions. We're going to determine if the roots or solutions to that equation are real roots, imaginary or complex roots, or repeating roots. So what is the discriminant? So the discriminant is the b squared minus 4ac part of our quadratic formula. That is what is the discriminant. So if we look here, this is our quadratic formula and used to solving quadratic equations. The b squared minus 4ac, that is known as the discriminant, right? So this part can tell us if we're going to have real roots, so roots that are real numbers, or the roots are imaginary, i.e. roots that are just imaginary or complex numbers, and we have repeated roots, i.e. the two solutions are the same. So how can that tell us this? So you need to remember all this. This is not in your log table, but if b squared minus 4ac is greater than 0, so recall this is for a quadratic equation in the form ax squared plus bx plus c. So we take our a, b, and c from this. So if b squared minus 4ac is greater than 0, the two roots are different and real, right? The two roots are different and real, and they cross the x-axis twice like that. If b squared minus 4ac equals 0, we have two equal roots, i.e. the quadratic touches 1 point, like this. If b squared minus 4ac is less than 0, we're going to have two imaginary roots, i.e. it does not cross the x-axis. And finally, if b squared minus 4ac, if it's a perfect square, i.e. it can be written as something squared, we're going to have rational roots. So roots or solutions that do not have a third or a square root in them. So that makes sense. So minus b plus or minus root b squared minus 4ac. So so if this part in here was minus, so let's just say I have, I don't know, minus 3 plus or minus, and in here I have 9. Let's just say 10. Let's say 10 all over 2a. Or just say just 2, right? This means I have two proper solutions. If I put this in my calculator, I'm going to get two actual solutions. I'm going to get x equals blah, 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 and x equals blah, blah, blah. If I say have this, x squared plus or minus root minus 9 all over 2. Now, right? So minus 3 plus or minus root 9. Well, you will learn about this in complex numbers, but square root of 9 is equal to 3i, right? So it is a complex number, so it will not have a real root. So remember, when I'm saying real, and imagine, I'm talking about real in the sense of the set of numbers, like the real numbers, which is like any number. And then finally, if I have it like this, minus 3 plus or minus square root of 9 all over 2, well, this is going to be minus 3 plus or minus 3 all over 2. And this is going to give me an actual kind of fraction. So this is going to give me 0 as a solution, and it's going to give me minus 3 as a solution. And then finally, last one is the repeated root, minus 3 plus or minus, say, square root of 0 all over 2. Well, that just means my two solutions are just minus 3 over 2, right? So let's look at some questiones. So here's some equations in the discriminant and the nature of said roots. So if the equation 2x squared minus 6x plus 4, well, the discriminant is b squared minus 4ac. So if I sub it in, b is minus 6, a is 2, and c is 4. I sub it all in, I get 36 minus 32 equals 4. 4 is greater than 0, therefore if they have real and distinct or real and different roots. And they do in this case because the roots of this equation are 1 and 2. 3x squared plus 4x plus 5. Well, if I sub it in, b is 4, a is 3, c is 5. I sub it all in, I'm going to get minus 44. Well, minus 44 is less than 0, so therefore I'm going to have a complex root, right? So no real root, so I have no actual proper solution for it. It doesn't cross the x-axis. Here, 5x squared minus 10x plus 5, a is equal to 5, b is minus 10, c is 5. Sub it all in. I'm going to get 0. 0 is equal to 0. So I'm going to have real and equal roots, right? So the only solution to this equation is x is equal to 1. So you're able to test this out for yourself by solving these equations, or to quickly find the nature of said root, you sub it into the discriminants. So here's an example of some questions we could be asked. Given the equation 3x squared, let me just not spoil this for us. Whoop. Right, so given the equation 3x squared minus 2kx plus k squared minus 6 equals 0, find the values of k for which the equation has equal roots. So equal roots is the key word here, equal real roots. So therefore my discriminant equals 0. So let's label my a, b, and c. So a is going to equal 3 because that's the coefficient of x squared. B is going to equal minus 2k. And then c is my constant part, which is k squared minus 6, which is noted here. So let's sub it in. B squared minus 4ac. So I have minus 2k, all to be squared, minus 4 times a times c, which is k squared minus 6. Let's see now if this equals 0. So let it equal 0. And then solve for k. So that's going to be 4k squared. That's going to be minus 12 times k squared minus 6 equals 0. 4k squared minus 12k plus 68. That's a lie. No, it's not. 72. My apologies. 72 equals 0. Minus, that's 8k, that's minus 12k squared. Minus 8k squared plus 72 equals 0. Minus 8k squared is equal to minus 72. So k squared is going to be equal to divide both sides by 8. It's going to be 9. Therefore, square root both sides. So since I have k squared is equal to something, k is going to equal to plus or minus 3. And there are my two solutions. So when k is plus 3 or when k is minus 3, this quadratic equation will have two equal roots. So let's look at this question here. Again, let's not spoil it for ourselves. We really should have rubbed it out beforehand, but oopsies. Right. So let's look at this question here. Given p minus 2 x squared plus 2x minus p equals 0, show that the roots are real for all values of p. So are real. So we have real roots, so they're greater than 0. And then part 2 is asking us, show that the roots are rational. So roots are rational. B squared minus 4ac is a perfect square. So real roots, b squared minus 4ac is greater than 0. So let's test, see if this holds, and see if we can get my left-hand side to be greater than 0. So b squared minus 4ac, so b is equal to 2. P minus 2 is going to be equal to a, and then c is going to equal to minus p. So b squared minus 4 times a times c. 4 minus, or plus 4p, p minus 2, 4 plus 4p squared minus 8, right, is greater than or equal to 0. So 4p squared minus 4 is greater than or equal to 0. Have I made a mistake anywhere? For AC, no, that's 8p here, my apologies, minus from plus 4p times minus 2 is minus 8p. Right, so that reward is going to equal to 4p squared minus 8p plus 4. So, this doesn't really, how can I prove this is greater than 0? This doesn't really lend itself to this, really. But in actuality, this is actually a perfect square. So this can be written as 2p minus 2 all to be squared, right? So if you factorize this, you get 2p minus 2 all to be squared. And is this going to be greater than or equal to 0? Yes, it is, right? Because it's something to be squared. So thus, anything squared is always greater than or equal to 0. So if I'm squaring a number or a term, it will always be positive. So therefore, 2p minus 2 all to be squared is greater than 0? Absolutely, because it's a squared number, so it will be positive. Remember, anything negative squared will be positive, and anything positive squared will be positive. Then, show that the roots are rational. Well, since 2p minus 2 squared is a perfect square, i.e. it's written as something squared. Since 2p minus 2 all to be squared is a perfect square, therefore the roots are rational, i.e. the roots will be numbers or solutions without certs. Always. Right, that's that one done. Let's look at some exam questions now. So this is from the 2022 Leaving Cert paper, paper 1, question 1. Find two values of m, elements of integers, for which the following equation in x has exactly one solution. So exactly one solution, i.e. equal roots. So b squared minus 4ac equals 0. So let's sub it in. So a is equal to 3, b is equal to minus m, and then c is equal to 3. So minus m all to be squared minus 4 times a, which is 3, times c, which is 3, equals, or has to equal 0. We want exactly one solution. So m squared minus 36 equals 0. M squared is going to equal 36. Then the two possible solutions for m, square both sides, I'm going to get plus or minus root 36, which is going to be plus or minus 6. So square both sides, square root of 36 gives me 6. But then since I'm square rooting a variable, I have to make sure I add the plus and minus there. So m is equal to plus or minus 6. Right, this is the 2010 paper now. So 2010 Leaving Cert Higher Level question 1. Given that p is a real number, prove that the equation x squared minus 4px minus x plus 2p equals 0 has real roots. So it has real roots. So I need to probably prove that my left-hand side is a perfect square. So remember, b squared minus 4ac is greater than or equal to 0. So a is equal to 1. B is going to equal to, so I have minus 4p minus x. Well, if I factor out a x here, I'm going to get minus 4p minus 1x. So therefore, b is going to equal to minus 4p minus 1. And then c is just my constant term here, which is just 2p. Sub it in, I get 4 minus 4p minus 1 all to be squared, minus 4 times a times c, which is 2p. Multiply this out, I get 16p squared plus 8p plus 1 minus 8p. So then, greater than or equal to 0. Well, simplify this now. The plus 8p and the minus 8p are going to cancel. I'm left with 16p squared plus 1 is greater than or equal to 0. That's true, because I have a positive number times a square number. This will always be positive. And I have a plus 1. So this term is always positive. And the 1 is a positive number. So therefore, it will always be greater than 0. So since 16p squared is always positive, and plus 1 is always positive, it has real roots because it's greater than or equal to 0. Finally, last question here. This is from the 2009 paper, paper 1, question 2. The graphs of 3 quadratic functions are shown here. In each case, state the nature of the roots of each function. So this one here does not cross the x-axis, so it's complex. It's complex roots. It doesn't have real solutions. This one only touches the graph once. So it has equal roots. And then this one here crosses the x-axis at 2 different points. So this is real and distinct roots. Right, let's look at part 2. The equation kx squared plus 1 minus kx plus k has equal roots. Find the possible values of k. So values, so remember you're probably going to have more than one value here. So b squared minus 4ac has equal roots, therefore equals 0. So 1 minus k, all to be squared, minus 4 times k equals 0. This multiplies out to 1 minus 2k plus k squared minus 4k squared equals 0. So I am going to have here minus 3k squared minus 2k plus 1 equals 0. That's going to be 3k squared plus 2k minus 1 equals 0. So I changed all of the signs because I want to get positives. I want to get a positive k squared. This is going to factorize to 3k k here. It's going to be a plus 1 here and a minus 1 here equals 0. Let each bracket equal 0. So I'm going to have 3k minus 1 equals 0. K plus 1 equals 0. I'm going to have 3k is equal to 1. K is equal to 1/3. And then k is going to equal to minus 1. And there are my 2 possible values for k there. Right, so these are very straightforward questions. You could easily be asked in your exam. You just need to recall and remember all of these formulas, or yeah, all these kind of key things to know, because these are not in your log tables. And I hope this video was some help to you guys, and I'll catch you guys later. Bye.